afternoon, everybody. My name is Tom Scase. I'm one of the senior technology consultants at Avecto, which is now a BombGuard company. Today, we're going to talk about how the removal of local admin privileges across an organization is going to be one of the best security improvements that you can make across your Windows estate. And also, we're going to touch on how it's actually now achievable overnight as well. If we first of all start by looking at the security landscape, we're actually facing more threats than ever. If we actually look at some of the numbers from the McAfee Labs report that was released on September 2018, so the very latest report, we see that there was actually 41 million new strains of malware samples identified in that quarter. And that relates to very close to 500,000 new strains of malware detected every single day. So, so how are we going to keep up with detection-based technologies when we've got this, this vast amount of new piece of malware which are discovered each day? And what's also been found in Forrester is that 80% of breaches involve admin rights. So businesses are very aware that having these overprivileged users, overprivileged accounts in an organization is something that we need to resolve. And one of the biggest misconceptions is that having local admin rights on an endpoint is harmless, and that it's isolated to that single machine. And that's actually incorrect. This is incorrect because hackers are looking for local admin rights so that they can get deeper access into the network and into the systems, the wider systems, into the wider area. And to give you some examples of these, what can actually be achieved with local admin rights, I think some of these may be a little bit of a surprise. Number one, if I'm a local administrator on my endpoint, we're obviously trying to enforce security controls onto our end users. And maybe we do things such as, trying to enforce group policies, for instance. As a local administrator on that machine, I could disable group policies that my IT department try and enforce on me. I could also stop security services. So I may be under the impression that the reason why my laptop is running slow is because my antivirus software is slowing it down. I could, if I wanted to, stop that AV running. I could turn off the firewalls, for instance. I could also delete, modify, replace protected files that I wouldn't normally be able to replace if I was a standard user. So protected areas of the file system, such as the Windows directory, the program files directory. If I'm a local administrator, I've got write permissions on those normally protected areas. I could also install certificates. So maybe these could be used in a man-in-the-middle attack. I've also got the capabilities to scan ports and network for vulnerabilities. We can also do things such as going from local admin into systems. So we may want to do that so that we can bypass Microsoft's UAC controls. So the inbuilt security of the Microsoft operating systems from Windows Vista, the UAC, the user account control message, we can bypass those if we've got access to the local admin accounts. I could actually create my own vulnerabilities. I think we forget that if we are patching our OSs regularly, yes, we're rolling out those patches, but I, as an administrator, I could uninstall those patches. I could create holes in the operating system again. And I can also hide my tracks. I could clear event logs, for instance. If I'm a local administrator, I can actually create new accounts. So I could create new user accounts. I could create new local administrator accounts while I am a local admin. And one of the things that I think people are quite surprised at as well, that I can actually go from local administrator to a domain administrator. Now, there's a video which shows you how this is actually achievable. So as a domain user who has local admin permissions on this machine, I could actually create a scheduled task which is going to add my domain user account, which is only a local administrator on this machine, into the domain admins group. Now, as a local administrator, I don't have the permissions to do that myself. But what I can do is create a scheduled task on this machine that's going to run at logon with the privileges of that user that is logging on. So if a domain administrator logs onto that desktop, the scheduled task runs, and that action that is now the privileged user, the domain administrator has the privileges to do, that scheduled task runs in the context of that domain administrator, adding my user's account silently in the background into that domain admins group. So, even though I am only a local administrator on that machine, we do have a lot of, it is a big security risk. And if you were following that there, you may now see that my user, Adam, the admin, has now been added into that domain administrators group, all with local admin permissions on that machine. So what do we do about it? What are the industry experts, the Gartners, the compliance mandates suggesting the way that we secure our environment is by following these 4 key security strategies? At the very top of their application whitelisting. Absolutely, we're advocates of that. Let's only trust the known good applications. Let's not try to detect the infinite known bad out there. We're not trying to detect known bad malware because you're always 2, 3, 4, 5 steps behind the cyber criminals when we've got 41 million new strains of malware as identified via the McAfee labs. Application patching. Obviously, if we have vulnerabilities in both the applications and the operating systems, let's patch them as quickly as possible. And number 4 on that list is reducing administrative users. And it's all these guys that are doing those recommendations, and the reason why they're recommending those is that if we follow those 4 strategies, we can actually mitigate the risk of 85% of cyber threats. So if these are the recommendations, those 4 steps, recommendations from the Gartners, from the compliance mandates, etc., why is everybody not following them? And it's typically because they're very difficult to implement or they're considered difficult to implement. And I'm going to show you how it doesn't have to be as difficult as it looks. And as I said, I'm from Avecto. Every year we release our own vulnerabilities reports. We're going through all the different vulnerabilities, and we can actually see how many of those could have been mitigated simply by removal of admin rights. If we actually look over the last 5 years at all of Microsoft's critical vulnerabilities, you take away admin rights out of the equation, 88% of those over the last 5 years would have been mitigated without admin privileges. So, I think the results speak for themselves. So this is what I was touching on a moment. Why is everybody not implementing whitelists? Why is everybody not taking away local admin privileges from all of their users? And I think it basically boils down to this impossible compromise. Yes, if we start on this little scale here of 0 to 100, 0% is our unmanaged endpoints. 100% is being a very locked down endpoint. So what do we do to secure the desktop? Well, we're going to enforce group policies on everybody. We're going to install AV. We're then going to make sure that we're patching our operating systems and maybe patching the vulnerable applications more often and more frequently. Then maybe we go ahead and implement a whitelist across our organization. We're now only allowing the known good to run in the environment, blocking the unknown. Anything that falls outside of the whitelist is blocked. And then we're removing everybody's admin permissions across the board, not just from the developers, the engineers. We're talking, let's remove them from even the help desk. But then that's going to be a bit of a problem when we actually need to work and we need to be productive and the help desk need to install applications and our developers start to moan because actually they want the end user experience that they have on their endpoints at home. So we've got to turn the security down slightly. We then were patching endpoints, but actually we've got a server there that we're not sure exactly what that server's doing, and we're scared to patch it because it's just working as it is at the moment, so maybe we don't patch that environment. We can't slow people down from doing their jobs. We can't, We want to make sure the environment is secure, but we also want to make sure that our end users are productive and remain productive. And is whitelisting going to work when we've got developers who develop code that need to test their own code? How can we enforce a whitelist onto those end users with that type of role in the business? We've got laptop users that are engineers that are out in the field that go to a customer site that need to potentially install a brand new piece of software which allows them to connect their laptop to the customer's piece of hardware. We can't enforce a whitelist to those users either. And then we've got those users that just say, I need admin rights to do my job. So we say it's this impossible compromise. We need to find the right level, that right balance between end user flexibility, end user productivity, and security. So luckily, we've got a technology which can help you out. And what I'm going to do is go into the demonstration to show you exactly what is possible. So if I duplicate my desktop, what we should see in a moment, see how I'm doing for time. Okay, just 1:15, great. Plenty of time to do some demos. Here we go. So what we're going to do now is I'm going to show you kind of some of the challenges associated with simply removing admin rights. I think we all agree that having local administrators logging onto desktops, logging onto servers is considered overprivileged. And the reason why it's overprivileged is because, if I'm a local admin, I said that I can go and disable security that the IT teams, IT security are trying to enforce on me. I can turn my AV off. I can disable the group policies, etc. And also, one of the problems is if I accidentally introduce a piece of malware into this environment, the malware can run in the context of that logged on user. And if I'm logged on as a local administrator, the piece of malware can run in that context of a local admin. And if I'm logged onto a server and a domain administrator is already logged onto that server and a piece of malware runs in the context of a local admin, it's got access to the cache credentials, and we can do pass the hash type attacks then. So yes, removal of admin rights is a huge security leap. But what does that typically mean from an end user productivity, end user flexibility point of view? Well, imagine that this user that's logged onto this Windows 10 1809 edition endpoint, imagine they used to be an administrator. Maybe they are a developer or an engineer, but what we've done is we've stripped their admin rights, so they're now just logging onto this desktop as a standard user. What this may mean is there could be applications which the IT teams have deployed using SCCM that could require admin rights just to simply execute. So this business app doesn't run now that I'm no longer an administrator. And I don't have these admin credentials that the Microsoft UAC message is prompting me for. But also when I was an administrator, I may have introduced my own apps, my own productivity tools that make me work more efficiently, and some of those applications may not work now that I'm a standard user. And also there's hundreds of features within the operating systems that need privileges to make the changes. So, even in this Windows 10 device, to make a change to my power settings, you see this little UAC symbol is going to mean it's going to trigger UAC if I'm not an administrator. And that's just to change the power settings. So, this is just to improve my end user experience, maybe to stop my machine going to sleep so often, but it's not necessarily a security risk. So who is now going to make this change? If I could do this previously as a local admin, I now will have to ring the help desk. So that was a help desk call, a help desk ticket that was unnecessary previously. And maybe I'll be happy for the help desk to remotely connect to my machine to make that change on my behalf once, but I'm not going to ring the help desk as a developer every morning when I need them to run my Visual Studio application. So this is where you get lots of resistance from the end user, say, I can't do my job anymore. I need my admin rights back. Luckily, with Avecto's DefendPoint products, we don't need to worry about the user that had admin privileges. We can take away their admin rights overnight, and we can use DefendPoint's privilege management capability to actually elevate the individual applications rather than give the user the local admin rights. So what we're going to do is I'm just going to switch on the product. So it was currently disabled on the endpoint. I'm using the group policy edition of DefendPoint, and I'm enabling what we class as work styles from our quick start policy. So I'll go into how the quick start policy works. It's an out-of-the-box enterprise production-ready policy that can be rolled out into any organization without understanding what all of your applications are, and you'll see exactly how that's possible. So what I've done now is I've enabled DefendPoint, I've enabled the privilege management capability. So this same standard user, I'm not going to log them off. They never have permanent admin rights. They never need temporary admin rights. They don't need access to a secondary account. What I'm going to do now is elevate the privileges of the executable. So this app that triggered UAC moments ago now just runs seamlessly. If I go into the control panel applet to make a change to my power options, we'll see that no longer are they challenged with that Microsoft UAC message. The user can just make those changes as they would have done when they were an administrator, but I'm logged on as that more secure standard user account. Now, the question that typically comes up there around this point is, well, how do we know what applications out there need admin rights? We don't want to take away the admin rights from our developers, from our engineers, from our C-level execs, and then all of a sudden they complain because there was an application that we missed that we didn't realize needed admin rights. Well, we've been assisting organizations over the last 10 years to achieve least privilege. So if you think of all the Windows operating systems along the way, we know of all the features and the control panel applets that are built into the operating system that need these privileges. So we've got out-of-the-box templates within our quick start policy, which you can select and pull from to fit your organization. We've also deployed to over 8 million endpoints globally with our professional services team. So the applications, those third-party tools that need privileges like the Visual Studios, etc., we've got a good idea of what those are. But probably what's the biggest feature within the product is how we handle the unknown. Because as much as we've got a good understanding of a large number of the tools out there and the operating system applications that need privileges, there's probably 10 times more out there that we don't know of. You know, each individual company have their own unique applications that their developers may use that are personal to them. There could be applications that they've developed internally that need privileges. So it's all about how we handle the unknown. The way that we do that is using two features within DefendPoint, and the first one is called User Account Control Interception. So the reason why I started the session by double-clicking on a number of these applications and all of those triggered the Microsoft UAC message. They're UAC-aware applications. So that Microsoft message is an indicator that for whatever reason, that application needs admin rights. It may write somewhere in the file system, the registry, a protected area. It doesn't matter why, the Windows OS is indicating that it needs admin rights. So what we can do with DefendPoint is we can use that as an indicator, and that's all we need to know about the app for us to be able to manage it, for us to be able to provide the admin privileges to that application because it triggered UAC, or would have triggered UAC. Now, obviously, if that's all we're looking for in the application, we don't necessarily want to seamlessly elevate and provide that application with those privileges, because we want to make sure that, number one, it is a business app, and it's not some malware, and it's not just triggered in the background and the user didn't initiate it. But if you imagine that this user was an administrator before, they had the privileges to authorize any application installation, to run anything with the privileges. Piece of malware that may be executed in the background before would have just taken those privileges. So what we do with DefendPoint is we start with a very flexible end-user experience. Our quick start policies come with out-of-the-box work styles that can provide an admin-like experience to somebody that used to be an administrator whilst they're logged on with that more secure standard user account. And the way that we do that is using our gated access messaging. So the messaging is one of the biggest features within DefendPoint's products. And what we're doing here is we're challenging the user for anything that is unknown using our gated access. So this application, the engineering app that I installed whilst I was an administrator, I don't have a policy or anything in my policy which is looking out for the application in particular. Just by the fact that it triggers UAC, we're going to manage it. But as I said, What we're going to do now is challenge the user, and this here is one of the very basic gated access messages. It can be fully customized, so I've customized it with the PDS logo. We can change the text, we can change the branding, we can change the language of these messages as well. So what we can do is we can have multiple versions of this message in multiple languages, and then based on the regional settings of the operating system, display the correct language, so very user-friendly. But the important thing here is this is just a challenge to the user saying, this application needs elevated privileges, it doesn't currently exist on a pre-authorized list. If you can confirm this is a business application and you're happy to have your actions audited, so that's an important thing, we're auditing the unknown, centralizing that event information so IT can see exactly what the users are running with or authorizing themselves. But the important thing is that application that we never knew existed in the environment, never knew it was installed on that user machine. That user that previously was an administrator is able to run the apps, the tasks, the scripts that they need to do their job. Now, that was an application that didn't exist on that, did exist, it was already installed, but privileges and the management of privileges doesn't just need to be applied to applications that are already installed. An installer, a new application that I want to introduce and install myself, might be a use case. And this is an installer, and this application is different to the one. It's got different metadata, it's got different qualities. So for instance, this application has been introduced by the user. So with DefendPoint, we can have a look at this. We've got over 27 different application matching criteria. And to differentiate between that application that triggers UAC and the one that was already installed, I know that this one was user introduced. So maybe I'm asking the user some different things to confirm before they do run this application. And here in this example, I'm asking the user to go and view the corporate application policy, pointing them to the network where they can have a read of the terms and conditions and what they should or should not introduce. But again, all I need to do is say, yes, I've accepted the policy. And as this standard user, I can go and install a new unknown application. And it's not just application installations. I could, if I had a bit more time, go through and just run through a new package installer, or maybe that application has a self-updater, and we can actually allow that to run and it update itself. Question?
If it was elevated, if you would choose to browse during the installation.
Yeah.
If you would browse to CMD and run it.
Yeah. I like the way you're thinking, because we've also thought of this. So what you're thinking there is, obviously, if you imagine that we've taken away admin rights, because I keep referring back to the first stage of a rollout. If you've got people that are administrators, we take away their admin rights and then we provide an admin-like experience with DefendPoint. But because we are now managing the privileges of the applications and maybe their child processes, we can also now manage what they can and can't do with those privileges. We've got some patented and very comprehensive anti-tamper technology in place, which, for instance, I can show you in a moment. So I don't want to show you exactly now because I'm going to touch on the additional features. But if the user elevated the computer management, for instance, I'm going to give the user the ability to do that, because if we don't know what the user needs to do their job, we've kind of got to give them the ability initially to do and elevate anything they need to whilst you're in this active discovery mode. Everything they do and everything they elevate that you've not got on a trusted list at the moment, you will get visibility of. So we'll know what they're doing. Maybe they try and do something untoward, and we can also take note of that. So elevating the computer management, what's the biggest problem of elevating computer management? If I used to be an administrator no longer, I may try and add myself back into the local admins group. And then we're back to square one. They've got the keys to the kingdom again. But what we can do is we've got anti-tamper protection, so any privileged application that we're elevating now, because we're doing it on behalf of the user, we can protect the SAM database, we can protect our service, we can protect our driver, we can protect our process. So the user actually can't circumvent our technology using one of our elevated processes. And I'll touch on a little bit more, and I can maybe go into some more of the demonstration a bit later on. But what I've shown so far is that's the first part of how we can handle the unknown, the UAC interception, but not all applications are UAC aware. We could have in-house applications that have been developed by our developers that don't trigger UAC. We could have legacy applications. And in my environment, 2 example applications that function in a similar way that aren't legacy apps, but Disk Manager. If I double-click Disk Manager as a standard user, it fails to run as expected. It tells me that I've not got the access rights. Not very helpful, maybe. Windows Firewall is another good example. It launches, doesn't trigger UAC, so we don't manage it automatically, but it gives a dirty error message. Now, for these applications, any application that doesn't function as expected, a legacy app, non-UAC aware, we can give the user the ability to force admin privileges onto that application using our on-demand functionality. So it's a simple right-click. We can either intercept and replace the normal run as admin that would exist in that context menu, or we can replace it. I've replaced it here, but as you can see, all we're doing now is, again, the gated access. What do you want the user to do to confirm that it's them? Maybe ask them to provide a reason, drop-down reasons, or even free text area, and I'm sure they'll just type a load of gobbledygook in there if they just ask free text. But here my user's asked to re-authenticate with their standard user passwords. So that application, which we didn't know of, needed admin rights, we're giving the user the ability to run these. And maybe my examples here, Disk Manager and the firewall, not the best example on a desktop. Maybe we don't want the user doing that, but think of server admins. Think of people in the help desk that are logging onto servers with local admin privileges. Local admin rights on a server is as much of a risk as a local admin on a desktop. We may have first-line support guys, the new guys into the IT department, that you let them log on as a local admin because we need them to restart the print spooler. Well, what if they accidentally reboot the machine? It's the applications that need the privileges, not the users. So all of those tasks that I was doing there, the on-demand functionality for the legacy apps, the UAC interception, anything that is unknown, wherever we saw a message, we're raising events, and that's important. When the users were local admins, you had no visibility of what they did, what they installed, what changes they made, but now any unknown privileged task, we're raising events, and I'll show you what they look like later. But one of the things I've just shown you there is the admin-like experience, but maybe not everybody needs that flexible end-user experience. Maybe we want to provide a different level of flexibility to maybe give some back. Maybe we've taken admin rights away from a majority of the users in the business, but I think one thing that we can relate to is someone wanting to install a printer driver, for instance. So maybe we were talking about engineers, developers before, but now we're just talking about somebody in the finance team. Maybe our C-level executive, the CFO, goes home one evening, needs to print off some important documents for a meeting the following day. His printer's broken, he goes and buys a new printer, and when he tries to install the printer, if we take away no admin rights, what happens? When they go to try and run it, UAC message. No good. If they can't get any internet access, no network connectivity, no one could go and remotely connect from the help desk to try and do this on their behalf. But what we can do there is with DefendPoint is we've got, again, a different level of gated access. This time, whereas before it was something that the user could self-authenticate against. I could just click yes to continue, I have to put my password in, or maybe drop down, select a reason. This message box is not something the user can self-authenticate. They need a secondary authorizer. But imagine this as being a truly offline situation. No network connection, no internet. All I've got is a phone signal. I can actually ring the help desk because what we've got here is this unique challenge code, which is generated based on a shared key, an algorithm that basically uses the user, the individual application that the user is trying to run as well. So that's unique to the user and the app. What I could do is ring the help desk, and the help desk have access to a response code generator. They also know the shared key, and this generator could be hidden behind a web front end, so they don't necessarily need to know what the shared key is. But the important thing here is they can obviously listen to the end user, understand the situation, why they need to run an application that doesn't currently match any of the rules in place. And if they're happy for them to continue, all they need to do is present them with the unique response code. They can put that into the message, and now the application is able to run with the privileges it needs. So what we can do is we can create policies as a kind of break the glass scenario. The worst case scenario is that they get this challenge message that the user can't self-authorize again, so it's effectively a block until they go to someone to get secondary authorization. So what we've seen there is that, hopefully you can see that we can absolutely take away admin rights from anyone in the business. And we're not just talking about the challenging end users like the developers, the engineers. We're talking about even the IT help desk that have local admin permissions on everybody's machine. The IT help desk don't need local admin permissions. If they, if what type of task is it they need to do? Well, maybe they need to log onto someone's machine to install an app. Well, I could just come over the shoulder to someone and just go, right, well, actually, you need to install an application. Yes, I'll authorize it. So I put my help desk credentials in there, standard user help desk credentials, and then we can run through the installation. So even as an IT support person, I don't need local admin rights on the devices that I'm supporting.
But what is the context that this installer is running?
Yep, so good question. What we actually do, the way that we manage applications is, I'll show you in a moment that not only do we do privilege management, but we also do application control, so application whitelisting. So we have got a kind of hook into each process that's running, and we're effectively hooking into the process, stopping the process from running, and then checking in our policy, where the number one, we allow the app to run yes or no. So maybe we want to block an app or allow it to run passively. But also we may want to elevate the privileges. If it's an application that we're going to elevate the privileges, what we actually do is we take your standard user token. So imagine it's me, Tom, I'm trying to run an app. DefendPoint takes Tom's standard user security token, adds the admin permissions to the token, and then passes the new custom token to the app. So the application is actually running in the context of me with admin permissions. So from an auditing perspective, we're actually, it's still you running the application. It's not a local admin account that we're doing a run as. So with all that kind of tracking and auditing exactly of what's going on, it's actually all done through the enterprise reporting. Now, one of the things that when let's say in that scenario that I used there, where the help desk person authorized the installation, we can either actually allow the installation to take place under the context of the user or as the authorizer. So the thing is, it's the application needs to be installed, and when it's installed, DefendPoint's doing the installation. So it doesn't really matter who is authorizing it. It's just really for the auditing purposes.
I bet it gets the privileges from the account that runs the service.
Well, yes. So the actual DefendPoint service is running in the system context. Yeah. So it's running in the system context. So you think and I'll touch on what just some of the anti-tamper features that I mentioned before. So we talked about the user maybe go into computer management. I could right-click run on demand. Bad example there. Let me go back and just give the user high flexibility again. So provide an admin-like experience. Go into my apps. Yes, the user. We may give them the privileges to run this application elevated. But even though they have, if I go to try and add myself back to the local admins group, because DefendPoint is managing the privileges of this application, when they go to hit add, we've got the protection on the SAM database there. And it's not just through computer management. We're actually managing all the API calls that could be used to add the user back into the local admins group. So whether they run a PowerShell command, a command in command prompts, we're still protecting that. And it's the same for if I elevated Task Manager and tried to kill the DefendPoint process. If I tried to stop the driver, because we're controlling the privileges, we've got patented anti-tamper, which will stop the user from being able to access that, and also the configuration that's local on that machine. 10 minutes to go, so there's a few things that I did want to show. So one of the things that we can also do with endpoint, if we've now stripped privileges away from all of our users, what we can also do is the number one recommended strategy, which was whitelisting. So whitelisting in an enterprise, most customers that have tried whitelisting, they've tried it and it's typically failed because of two reasons. Number one is that whitelisting typically means managing a list of known good executables or SHA-1 hashes of all of the applications on that go-build desktop or server. And that works momentarily because then we find there's a vulnerability in one of the apps. So we roll out the new update of Adobe Reader, and then the SHA-1 hashes of those new executables don't match the ones in the whitelist. So that application's blocked until we update the whitelist. So very difficult to maintain that list in that traditional way. And also, we're talking about, as we said, developers, engineers who need to introduce apps. A whitelist is never going to be something we could enforce on those users. But that's all a change when you can actually think of how we can do things with endpoint. If I actually show you what my whitelist looks like, my whitelist is a single entry. And that single entry, let me go back. So it's a single entry. It's not a list of thousands of SHA-1 hashes. And that single entry has actually got a wildcard for the executable. So we don't care what the executable's called. We don't care what the path is. We don't care who the vendor is. The one property that we do care about is this property known as trusted ownership. So what is trusted ownership? Well, trusted ownership is based on NTFS permissions. Because of NTFS permissions, every single executable on the desktops and the servers, every single executable has an owner. And if we actually look at the user, the standard user context, one thing all of these applications that my user has introduced, one thing that they all have in common is that they have been introduced by that user. And because of NTFS permissions, as soon as they hit the disk, whether I've downloaded them off the internet, brought them in on a USB stick, received something over an email, as soon as it drops to disk, the user is the owner. So if I go and look at the security, and you can check this on any of the machines, standard users, the owner is the user account. Now, a lot of people say, oh, well, I can change that. Well, you can't change it if you were no longer an administrator. And endpoint, as much as we could have handled the unknown, we can block stuff. So, the user can't change that. So what that means is we can leverage that. And first of all, let me just turn off endpoint, because I just want to show you that obviously that some of these applications will run. If even as a standard user, I could go and introduce this unknown executable, and what's to say something malicious isn't attached. I could also go and run through an installation of this torrent application. Maybe if I try to install it into program files, what's going to happen? It's going to get blocked or stopped because the standard user can't install to program files. But these applications, just like Spotify's, Dropboxes of the world, Google Chrome, you can install into the user profile. So even as a standard user, I can install these applications into my user profile. And torrent apps may not get flagged as being malware, but they're a very good way of introducing malware, a great way of introducing unlicensed software. So this is why we want to implement whitelisting. And also, why would we want to implement a whitelist? Well, think of ransomware attacks. I've got some documents on my desktop that obviously I'm a standard user, I'm not an admin, as you've just seen. And the problem with ransomware is it targets content. And content can be zipped up, can be encrypted as a standard user. And that's effectively what ransomware does. And this, clicking on the link, took me to a fake website that exploited a vulnerability in my web browser. And all it did was drop this unknown Adobe executable into my user's profile. It ran in the context of a standard user, and that's all the credentials, all the privileges it needs to go and encrypt all my data. So we see on the desktop all my data has been encrypted. That's no good. So that's all under the context of a standard user. So let's show you what we can do with endpoint. I've just said that we can make whitelisting simple. So I've shown you what it looks like for applications that are introduced by a user. They're all owned by a user. So Trusted ownership is slightly different because what we do with trusted ownership, or what trusted ownership is if we think of applications that have actually been introduced by a true admin account, so think of the likes of SCCM or any application delivery mechanisms that you use to deploy apps, they're being installed on the endpoint as a true admin. So your SCCM as a service account, which is installing the apps on the endpoint in the context of a real administrator. The difference there between the ownership of those applications that hit the endpoint is they're not owned by that SCCM installer account. They're owned by one of 3 accounts. There'll be trusted installer, the system account, or the built-in administrators group. And that's a fixed set of 3 accounts that if you use an admin account to install an app, it'll be one of those 3 accounts. So what we do is we class those 3 accounts as being trusted owners. So what that means then, if we look at my whitelist, any application that you've already deployed via SCCM or application delivery mechanisms, they're already owned by a trusted owner, so they're automatically whitelisted. Any applications you continue to roll out in the future use the same delivery mechanisms, they're automatically whitelisted. You don't have to keep updating the whitelist when you roll out a new app. It's just roll it out with the trusted delivery tools and it's automatically whitelisted. But then the second problem with whitelist, so that's made management very simple. We can roll out the whitelist, but remember our developer who creates his own code. Just because something falls outside of the whitelist doesn't mean it has to be a hard block like you'd see with the app lockers, etc. It just blocks it. No, you can't run it. That's the only option. But we've got gated access messaging that could be enough as a block, enough to challenge that developer and say, can you just confirm, Mr. Developer, that this application is something you developed? If yes, click continue. So we're getting that little bit of flexibility back to that user who may need that flexibility. We can absolutely put policies in place so we actually do have the default deny type whitelisting. You know, the most secure way of protecting the environment. Anything that's not delivered via SCCM or IT is blocked. And that can be shown in my drive-by download that took place before. You know, I said that anything that's introduced by the user, however it's introduced, whether they knowingly download something off the internet or actually they click on a link and it takes them to a fake website, there's a drive-by download. When that executable hits the disk, NCFS permissions rubber stamps it with the user as the owner. The user is not a trusted owner, so it falls outside of the whitelist. So in this case, it's blocked. But one other feature that we've got within DefendPoint that I'll touch on very quickly is known as trusted application protection. Because the cyber criminals are getting wise to the fact that dropping a binary to disk is a very traditional way of the attack, but let's use whitelisted applications in the attack now. So maybe instead it's not a new binary hitting the disk, but instead it's a malicious Word document that has a malicious Word document in there that has a macro. We trick the user into enabling the macro, and then PowerShell launches a child process, and PowerShell goes and encrypts all the data. You know, but these are 2 whitelisted applications. I'm a developer and I use PowerShell and I also use Microsoft Word. So how do we prevent them from being used in an attack but still allow the users to run them on a day-to-day basis? Well, one of the great features within DefendPoint is that not only can we manage applications and their child processes, but we can also make rules up based on who the parents were of an application. So you can see here that if I'm going to enable trusted application protection, and just first of all, I'm going to show you that this user can run PowerShell. This user can go and launch the command prompt. But what we're going to now is we've got rules in place. So for high-risk applications like web browsers, like your Office applications and Adobe Reader, if you think of getting an email in, what's that malicious email going to contain? It'll be either a hyperlink that opens up a web browser, which is vulnerable, an email attachment that might be a Word document, an Excel document, or a malicious PDF. So what we do is we add this additional layer of protection, not to the individual applications, the Words, the Office apps, the Adobe Readers, but it's to the child processes. Because if PowerShell is launched as a child process to any of those high-risk applications, Should it really be run as a child process to Word? Should the command prompt be launched as a child process to Adobe Reader? Should a malicious, unseen, unsigned DLL be allowed to load into Microsoft Excel? Well, what we can do is with trusted application protection, we can put that in place. So in that attack, before the drive-by download actually takes place, the web browser calls Java. Java then calls the command prompt. So we can actually block the command prompt from being launched because of its parent was a high-risk application. In the same way, that user was tricked into clicking and enabling the macro, the malicious macro. Because PowerShell was launched a child process to Microsoft Word, we can block PowerShell being launched. So it's all about that contextual awareness. The user can absolutely go and launch PowerShell, as you just saw a moment ago, but because we can make these decisions based on what the application is, where it was run, was it launched from Explorer, was it launched from a child process of a high-risk app, change the policy. And I'm coming to the very end of the time now, but what I said was almost as important as everything I've shown you is that now we can give you visibility of exactly what's been going on. So here we've got the enterprise reporting, and if I just refresh this, since I've been doing the demonstration, there was lots of applications that I may have authorized. There's been things that have been discovered. So net new applications that have been discovered, we can see that. We can track why have we got people logging on as local admins now, because it's all about removal of local admin privileges. Well, actually, it was one person on one endpoint logging on twice, so we can target that. We can see the trusted application incidents, so they're indicators of attack. And these are the two areas where I said before that we've got these out-of-the-box policies that you can roll out into any organization because of the exception handling capabilities, the UAC interception and on-demand, which allow us to manage any apps that need the privileges. But what we can do is we can go and have a look at them, and not only do we see things in there, so there's my Canon printer driver, I've got the process. If I click on that process, we can actually see a lot more about the metadata, or a lot more about the app, so who the user was, what the device was. Click on here, you'll see that we've got lots of metadata about it, including the SHA-1 hash, the publisher. But if we scroll down, not only have we got the application information, but its child processes. So this setup.exe, think of it as the self-extracting zip for that printer, that driver, and here's all the true driver information. You've got product versions and command line, etc. So you can use this to build new policies. And finally, very, very finally, I'm going to get called off in a moment, is that I said these out-of-the-box policies, not only can we start with a very flexible end-user experience, but what we can do is we can improve the policy. So, we don't want the engineer to keep having to click in on these types of messages just so that they can run their application. We don't want them to have to keep right-clicking on Windows Firewall when they need to launch the app because it was a non-UAC aware application. So what we can do is the way that we can change that is if I just go into the policy, we've got applications that we can group together that we want to manage in the same way. So this application that's on the desktop that just runs seamlessly, it's because we've identified it before and we've stuck it in a pre-authorized list. And this pre-authorized list is this one. I can right-click, insert all the different application types, but at the very bottom there, we've got the events, and that means we can pull in event information from the enterprise reports. I can say what applications triggered UAC. There's 8 of them. Let's have a look at the ones that came in today, 6. I can then go and select my application from the list. It pulls in all the metadata that we can use, so I can go and select the file hash, the command line if I want to. I can take things out of there. I know it needs child processes to be managed, and there's a very simple addition to my policy. The same again if I just click through and go to the right, it was the launch of the shell menu for the Windows Firewall. So it's not a UAC triggered one, but I can quickly add it to the list. Windows Firewall, click OK. Maybe make a quick change, don't need the command line. Push out that policy. And then within, just by identifying stuff that's through our enterprise reports with the out-of-the-box policies, that application now runs seamlessly. Windows Firewall now runs seamlessly with the privileges it needs. And that's all using DefendPoint with its out-of-the-box policies, the quick start policy, capable of handling the unknown with the UAC interception and the on-demand functionality, enterprise reports giving you the visibility of what the end users are doing, and then the next phase of the rollout, you can actually improve the policy and improve the security, improve the end user experience. So just to summarize, I think everything that you've seen, if I just go to, I won't summarize as in summarize, but just like to finish off to say, thanks everybody for coming to the session. If you could do, if my screen catches up, is please fill in the evaluation forms. Any questions? I'm just over at the Bomgar and the Vecto stand in the left-hand side, and I'll happily answer any further questions there. But thanks for your time. Thanks.